Hello everyone. This is lecture number 2 of gravitation. In this lecture, I am going to discuss gravitational field intensity due to masses. Okay. So mainly we will discuss about the gravitational field. Gravitational field intensity. So first we will define it. Gravitational field intensity. How it is defined? This is defined as if there is system of masses will apply any force on test mass. That means unit kg mass. Whatever force applied on unit kg mass, that will become intensity of gravitational field due to system of masses. For example, if I'm saying there is some system of masses, this is system of masses. That means there may be number of masses. Okay, let's pick here a point P, and at this point you keep here test mass. This is M test mass. We will calculate how much this system of masses applying force on it. That force will be of course attractive in nature. So whatever force is acting here on test mass, gravitational field we have to find out at this point due to this masses. So I will write here E equal to this Fg upon test mass. Clear? So this is how we will calculate in vector form if I am writing. So this will be gravitational force upon that test mass. That means overall what we are doing on unit kg mass, if you keep here, so m naught equal to 1 kg, so this force will become E. That means whatever force acting on unit kg mass, that force will represent gravitational field at that point. Clear? So we can define it now. It is defined as force acting on test mass. That means unit kg. It is defined as force acting on test mass due to system of masses. Or maybe there will be a single mass. Okay, there is single mass. So single mass, how much force is applying here? Okay, so this is how we will calculate single mass or system of masses applying some force here on test mass. So we will calculate force on unit kg mass, that will become gravitational field. Now this is, if unit I want to write, so unit is Newton per kg. This is vector quantity because force is a vector quantity, so this will be also a vector quantity. Now direction of E will be parallel to direction of F. Next, if E given force you want to find out, simply you can multiply mass to gravitational field, you will get force. Okay, so field is known, you can multiply with mass, you will get force here. Okay, now next topic, gravitational field due to point mass. Gravitational field due to point mass. So I'm taking here one point mass, that is M. I want to find out field at r distance from this point mass. This is the point P. Let's take point P. We have to find out gravitational field at P point due to this M mass. Okay. So how will I find out? I will put here one test mass, that is test mass. I will calculate here force on this test mass. So how much will be force? That force will be of course attractive in nature. So this M will attract M naught. This is gravitational force. So this force value will be how much? G into M naught upon R square. So we have to find out field here. So field is defined as force on unit kg mass. This value is G M naught upon R square into M naught. This value is cancelled. I am getting here Gm upon R square. So this is value of field, Gm upon R square. That means we got here due to point mass filled at r distance is gm upon r square. This formula we are getting. If in vector form we want to write, so we can write this value gm upon r square into what is the vector. Vector will be along this direction. Along this means vector r I am assuming here right side. So this is gravitational field is left side. So I can write here minus r cap. R cap is unit vector. Okay. So this value we can also write in this form gm upon this is r square r cap. Or we can also write in this form r cap is vector r upon mod r. So we can also write minus g and vector r upon r cube. Clear? So better this one. Okay. Otherwise we can also write in this form. Okay. So this is gravitational field due to point mass. Now let's take here question. I'm saying that this is a triangle, equilateral triangle. Two masses are kept at vertex of this equilateral triangle. This is one and this is another one. So find out, this is a point A. Okay, so find gravitational field E at point A. Okay, at vertex A. At vertex A. Okay, so here I want to find out field. So what will I do here? This will apply field and this field will be attractive like this. Due to this field will be along this. Okay. So let's take this is E value. So this will be also E value because same distance, same mass, same mass. So value will be same but direction will be different. Okay. So here, what is this E value? E value will be, we can write here that gravitational field due to one point mass is gm upon a square. Now there are two vector acting at point A. This is E and angle between them is 60. So we can write here what is resultant. Resultant will be, I can write it in this form also. Let's take here one bisector line. So this angle is 30, this angle is also 30. So E cos 30, E cos 30. E cos 30 and due to this component along this direction is also E cos 30. So here what net I am getting, this will be, this component will be equal and opposite cancel out, means this will be E sin 30, this will be also E sin 30, E sin 30, E sin 30 will be cancel out. So E net I am getting here 2E cos 30 and cos 30 is, so this value is E root 3. Clear? And what is value of E? E value is gm upon a square into root 3. This is answer we are getting. Okay. So gravitational field due to 2-point mass at a point is this much net. Clear? Let's take here one more question. If I am saying this is, let's take coordinate y0 comma a, this is 0 comma minus a. Okay, along y we have taken 2-point mass, this is m, this is another m. Okay, find out gravitational field at certain point. Let's take this is a point P and this distance is given here x, this distance is given here x. So find gravitational field E at point P, okay, as shown in figure. Okay, so question is shown in figure, that means m distance given, this is a, this is a, x distance, point P, we have to find out gravitational field at point P. Okay, so what will I do here? This is not difficult, only vector summation. Tell me what is gravitational field due to point mass due to this point mass at P point. So this value will be this one line. If you connect here, so this will be connecting line. So along this direction, this is, let's take E. So this will be also connect here. This will also be E. Now this is E. Let's take here theta. So this will be also theta. Now I will find out this theta value. So let me put here what is resultant. Along this direction E sin, along this E sin, this will be cancelled out. So net I will get here, because this is vector quantity, that's why we have to add it like vector. So E cos theta along this E, again E cos theta. So E net will be 2E cos theta. What is value of E? E value is due to this one at this point. So what is this distance? A square plus x square. Okay, this is hypotenuse. This is A, this is x. So I can write here E is G m upon distance between this point is A square plus x square. Okay, because this is hypotenuse square. Okay, gm upon distance square I have to take. So distance between this and this point is this much into cos theta. What is cos theta? Cos theta we can write base upon hypotenuse. Base is x, hypotenuse is under root a square plus x square. So final answer I am getting here. This is 2 g m x upon, this is I can write a square plus x square to the power 3 by 2. So this is value of E I am getting. Okay. Further they can ask at what x, if you put here x equal to 0, we will get here field how much? 0, because there is in numerator there is x. So x equal to 0, that means at this point gravitational field is 0. Again if I put x equal to infinity, again this E will be 0. So here from this point if you are moving, gravitational field is increasing, it will go to a certain maximum value, again that value will decrease further. Okay, so we have to find out one more value, at what x value of E will be maximum. Okay, this is, if you have to find out, so what you have to do, just put d upon dx equal to 0, because this is function of x. Put d upon dx, we will get here x value, that would be r upon root 2. It will be basically plus minus r upon root 2. So at that point, if I put x equal to this much, I will get E value, that E will be maximum. So if they are asking at what x value of E will be maximum, we can find out like that. Okay. Next one, gravitational field due to semicircular ring. Okay, due to an arc, due to hollow sphere, solid sphere. Okay, we have to calculate. Okay, this much gravitational field. So next one, okay. So next point is gravitational field due to semicircular ring. Okay. So next topic, gravitational field. Gravitational field due to semicircular ring. Semicircular ring. Okay. So semicircular ring means mass will be given. This mass is given m, radius given r. This is semicircular. We have to find out gravitational field at this center point. Okay. So this is the point. Let's take this is x and this is y. So we have to find out gravitational field at this point. Okay. So here you can see here from common sense you can judge. Right side 50%, left side 50%. Okay. So here gravitational field along x direction will be 0. Okay, because it is symmetry. Right side, left side symmetry. Only gravitational field will be due to this ring outside. Okay, so let me calculate that value. Okay, I will not assume, I will calculate and I will prove that Ex will be 0, Ey will be something, that value I have to calculate. So here gravitational field due to ring, here at O point, so I am writing here at O point net field is some Ex I cap plus Ey j cap. Clear? So let me calculate Ex. Ex means only component which is along this direction. So here I will assume here at theta angle, some d theta part, very elemental part. This angle is d theta, this angle is d theta. So what is this length? This length will be r into d theta. Okay, you know that r equal to radius into theta. Okay, so mass of this part is how much? Let's take dm. So dm will be equal to, I can write here, let me calculate lambda, that is linear mass density. Linear mass density. So here what is given? Mass given. What is length of this ring? That is pi r. Okay, half of the circle. So this is lambda. So what is dm? Dm is r into d theta into lambda. This is dm. Okay, elemental mass. I am taking here one elemental mass. That is very small mass I am taking on this ring. Okay. So this is dm. What is now this dm? You can consider point mass. So due to this dm, what is field here? That field will be, of course, along this direction only. This is de. D very small. So this de is how much? This d will be equal to, I can write here, g into dm upon what is distance? This is r square. So this is field d. Okay. Now I can take here component of d along x, that would be along x, that would be d cos theta, and along y de sin theta. Now when I want this x is dx, this much I want complete e along x direction, so I can write here this is dex integration. Similarly I can write here ey equal to dy. Okay, this is how you will calculate ex and ey. So let me calculate this dx value. Okay, so dx I want to calculate first ex. So this is dx integration. What is d? D cos theta. What is d? D is g dm upon r square into cos theta. Now I have to integrate it. Clear? From where to where? If I increase theta from 0 to 180, I will cover whole this ring. Okay, semicircular ring. That's why I'll put here limit 0 to pi. Okay, 180 angle. So what I put here, value of dm. Value of dm, that means elemental mass is, we can put here g upon r square constant, take outside. Dm I am putting r lambda d theta. So r lambda is again constant, take it outside. Okay, so here I am getting g by r square outside, in place of dm r lambda outside, so d theta inside and cos theta. So if I write here, 1 r cancel out, so this is g lambda upon r and cos theta d theta integration 0 to pi. What is integration of cos theta? That is cos theta sin theta. Okay, so this will be g lambda upon r, integration of cos theta is sin theta 0 to pi. So I will get here, this value is g lambda upon r and sin pi minus sin 0. What is sin pi? 0. Sin 0 also 0. So this is what I am getting, 0 minus 0. This is 0. So gravitational field along x direction is 0. That means if there is semicircular ring, okay, so only gravitational field will be along ey. Ex is 0 here I am getting. Okay, so conclusion here is ex 0. One conclusion. Now let me calculate ey. This is integration dey. This value is, again I can write similar concept. So de, that is g dm upon r square into sin theta. Okay, what is dm? Again dm equal to r lambda d theta. So r lambda let me take outside, so I can write here g by r square, and if I am putting dm this much, so r lambda I am taking outside, integration sin theta d theta, 1 r cancel out, I am getting here g lambda upon r. Now what is limit? Again limit will be same. I want to cover whole this ring, semicircular ring. So sin theta, what is integration of sin theta? That is minus cos theta. So I can write here minus cos theta, that is equal to 0 to pi. Let me put here, let me take minus outside, so g lambda upon r. Now what is cos pi? cos pi minus 1. So this value is minus g lambda upon, this is r. Cos pi is minus 1 and cos 0 is 1. So this is minus 2 and it will make 2g lambda upon r. So this is what we are getting. E net we are getting along x direction 0. Along y direction only we are getting, and that value is 2g lambda upon r. No need of negative. This is j. So this is gravitational field we are getting due to semicircular ring. Okay, if I put this ring like this, so gravitational field will be along this direction. So value will be same, 2g lambda upon r. Okay, 2g lambda upon r, but along x direction. So here answer would be 2g lambda upon r into I cap, because along bisector line, okay, this field will be. What is lambda here? Lambda if not given, so lambda you can put m upon how much? Pi r. So this value if you put, then this value will convert into 2g 2gm upon 2gm upon pi r square, okay, into j. So this is answer. This one most popular in form of lambda. Otherwise lambda not given, we can calculate like that also. Okay. Next one, we will calculate due to arc. Okay, gravitational field due to arc. That will be general condition. If we put different theta, we'll get uh, gravitational field. So gravitational field due to an arc. Okay. So arc. Let's take a linear density given. Okay, lambda is linear density, or they can give mass also. Linear density. Linear density means mass per unit length. Okay. So here this is r given, and this arc is making some angle at center. This is center. This is r, and this angle is theta. Okay. So here lambda given, lambda is linear mass density given. Okay, we have to find out field at this point. Okay, this is center, we have to find out field at center. So let me divide this one in two parts. Okay, so this one is two part. This part is theta by 2, this part is also theta by 2. Clear? Now what I am going to do, I am going to take an element here. Okay, let me say this is alpha. Okay, so this is alpha by 2, this is also alpha by 2. Clear? So what I am going to take here, at theta angle I am going to take an element here of d theta. Okay, so this is very small part, this small part length, this angle is theta, this angle is d theta, this angle is d theta. Okay, d theta. So what is the length of this much part? What is the length of this much part? So this much part length I can write r into d theta. Okay, because r equal to radius into theta. I am interested in mass. So what is mass of this part? This is length. So what is mass here? Mass dm, I can write length into linear mass density. Length we have calculated. Now what is field due to this one, dm mass at this point? That would be, I can write here, this is the ring and I want to find out field here. So this will be d, this is d. Okay, this is d. So similar, I will take one element here also at same angle. Okay, so I can write here this is d. Okay, so this angle is theta, this is also theta. So what net I will get? D net means two element I have taken. Right side theta angle d theta, left side also theta angle d theta. So that one I'm getting left side. So what is DE net? I will get here DE cos theta, DE cos theta. DE sin theta will be neutralized. DE sin theta, this DE sin theta will be cancelled out. Okay, so this will be 0. Net I will get DE cos theta and 2 twice. Clear? What is value of DE? DE value is 2 into what is DE? Due to point mass filled here. So that value I can write G into dm upon r square into cos theta. What is dm? R d theta lambda. So this is 2G and upon r square. Dm I can put r into lambda into d theta. I can write later on cos theta d theta. This is d in it. What I want, complete field, complete field. So what I have to do? Integrate dE. So this value, if you integrate r cancel out, I am getting here 2G lambda upon r. Now, what is integration of cos theta d theta? We have to integrate it from 0 to only half part. Why? Because left part I have also already covered 2DE net representing here. That means only this much part if I calculate. So this one is already added now. So we have to calculate for only half part. Okay, twice we have already done. So this value is 0 to alpha by 2 because maximum value it can go to alpha by 2. So this value is how much? 2G lambda upon r. Now cos theta integration is sin theta. Sin theta if I put limit, so sin alpha by 2 minus sin 0. So final formula I am getting here. This is equal to 2G lambda sin alpha by 2 upon so this is very important formula. For example, this one I am applying there. So there what is in place of alpha? This complete angle is alpha. What is in place of alpha? 180. So put here 180. So sin 180 upon 2 sin 90. So this value will convert into 2G lambda upon r. Same thing we have already got 2G lambda upon r. Suppose this is quarter circle. Okay. Suppose I am saying this is x and this is y. Okay, this is quarter circle. This must part. Find the gravitational field due to this part. So first thing is that this vector will be along bisector line. Okay, so in vector form, find gravitational field will be along this line only. Let's take here lambda given and radius given r. So this is one quarter circle. We have to find out gravitational field due to this quarter arc. Okay, at center. So this field will be along bisector line only. So what would be this value? Okay, this value will be 2G lambda upon r. What is this angle? This angle is 90. So sine 90 upon 2. Clear? Now this is value. This is okay. Sine 90 upon 2, sine 45, 1 upon root 2. So if I divide, it will come root 2 g lambda upon r. This is okay in value. But they have asked question that in vector form. So in vector form, if I am writing, so this value will be along bisector line. So along bisector line, I plus j and upon root 2 we have to do. So this is 2g lambda upon r. Along bisector line, what is unit vector? That is I plus j and magnitude of this vector is this much. So I can write in vector form, this root 2 cancel out. So g lambda upon r I plus j. So this is how we can calculate. Okay. So here what is question? If r given, find the gravitational field in vector form with this one, in value this much. Okay. This is how you will calculate for an r. Okay. So this formula is very important. 2G lambda upon r into sine alpha upon 2. Clear? Next one, gravitational field due to ring on its axis. Gravitational field due to ring on its axis. Okay, natural axis. So this is the ring I'm taking. This is a ring. Let's take mass and radius r. We have to find out field at this point. Let's take this here point P and this distance given here x. We have to find out the gravitational field at x distance, okay, on its axis. Okay, so here we have to find out field. So what will I do here? I will derive it, okay, and that formula you have to remember. Let's take here very small mass dm. This one also very small, just opposite, okay, opposite dm here. Now this value is how much? This value is r. This value is also r. What is this value? This value is going to be r square plus x square under root. So exactly this one is also going to be r square plus x square under root. Okay. So let me calculate due to this point dm mass at this point. So this field will be dE. What would be d? Here also d. What would be this d? G into dm upon what is distance here? R square plus x square root. So square, it will be only this much. Okay, distance square. So this will be this much. So here assume that this angle is theta. This is also theta. Now d sin theta cancel out. D cos theta means due to this d cos theta, due to this d cos theta. So net field I will get here at center, that is equal to 2 d cos theta. I can write here 2 into what is de? G into dm upon r square plus x square into cos theta. Now this is de. Okay, cos theta is variable or constant? Cos theta constant here, theta is not changing. Okay, if you take any point on ring, theta will be, this is just a cone. Okay, so theta will remain same. So if I'm getting here E net, D net, so whatever is constant take outside. So 2g cos theta upon r square plus x square. Now dm only integrated. But already I have taken 2 dm, twice we have already done. So dm integration will be only m by 2. Okay, if only one element I have taken, one elemental mass dm I have taken, so integration of dm will be dm. If twice dm already I have done, because of 2 dm I have calculated this much field. So if you integrate, it will be up to m by 2. So this e you will get here how much? This is m by 2. So 2 cancel, and g into cos theta we can put here value. Cos theta is based upon hypotenuse. So g into m, g into m into x upon 2, here m by 2 if I put, so 2 cancel. So g m, because m will come, so this will be r square plus x square power. So this is very important. Again here they have asked x equal to 0, field is 0. X equal to infinity, field is 0. Okay, so at what x field will be maximum? So I have to differentiate it with respect to x. I will get same type answer. Okay, so x equal to r by root 2, field will be maximum. D upon dx will be 0. That means at this x it is going to be maximum. Okay, so this is further question if they are asking at what x field will be maximum. So if you differentiate for 0, you will get this answer. Okay, so this is gravitational field due to one ring on its axis. Okay, and similarly due to disk also you remember this is E due to disk of mass m, radius r. Okay, so this is now on its axis we have to find out. Now this is disk. Okay, so here at x distance you want to find out field here. This is mass m, radius r. So formula only remember Otherwise, we have to imagine one many ring from 0 radius to capital R radius, it will become a disk. Okay, so we have to integrate. Only formula is important here. You can remember here, this is 2 G M upon, this is R square, and this is 1 minus cos theta. Okay, where what is theta? If you connect this, so whatever angle it is making, that is cos theta. You can remember this answer. Okay, so this is disk, this is ring. Two more, we have to calculate due to solid sphere and hollow sphere gravitational field. Okay. Next, gravitational field due to gravitational field due to hollow sphere. Hollow sphere of mass m, radius y. Okay. So I will take here 3.1 inside, 1 at surface, and third one outside. So this is M and R, and this is hollow. Okay. So hollow, there will be 3 points. Okay. So first point, okay, case 1 I'm taking R less than R. That means inside point. Inside. So here E inside will be always 0. Okay, you have to remember 0. Why 0? Because if I take here any point, so I can divide it into two parts, right side, left side. So you can say, sir, left side is more mass, so it should be more. So distance is also more. Right side less mass, but distance is also less. So here this part will apply field like this. This part will apply field like this. It will be equal and opposite at 0. Okay. So it is proved also. Okay. We have seen it also. That's why inside hollow sphere field will be always 0. Okay. Case 2, when R equal to R. Okay. That means at surface. So at surface, it will be surface. This will be Gm upon R square. Okay. You can write Gm upon R square. And case 3, when R is greater than, that means outside. So outside point, it will be have like a point mass. Okay. So formula will be outside. It will be have like a point mass. So Gm upon R square, not capital R, small r square. So it will behave like point mass. If I'm plotting here curve, so let's take here, this is center line. Okay, so this is E I'm saying, and this is R I'm saying. So field will be 0 from center to surface. So this is field 0. Suddenly field will increase in value if I'm writing. In vector form if I'm writing, so this outside will be minus Gm by R square into R cap. Okay, so in value I'm writing here, value I'm plotting. So this value will be, suddenly it will increase, again it will decrease to 0. So E will be proportional to 1 upon R square outside. E will be 0 inside, and this is small r equal to capital R. Okay, at surface field will be maximum, that maximum value is Gm upon R square. So what is maximum value of field? Gm upon R square. Where? At surface. Inside 0. Outside it will behave like this. Okay, it will decrease if you go away. Okay. So next one, if solid sphere I'm taking, solid sphere of mass and radius r. Okay. So here this one is solid sphere. Now solid. This is solid. So again there will be three cases. Okay. Case 1. Case 1 I'm taking outside. Okay, so outside point, that means R greater than outside. So again it will be have like a point mass, similar formula will come here. So outside it will be Gm by R square. Clear? At surface, case 2. So case 2 means small r equal to capital R, that means at surface. Okay, at surface this formula will be, this is E equal to Gm by R square. So same outside and surface it will become like same, hollow and solid. Only difference is inside. So case 3 I am taking. Okay, so R less than, that means inside. So now this is solid sphere. Okay, so this is solid, I can derive this formula. Here let's take, I want to find out here gravitational field. This is center, this is center. So what will I do here? I will imagine one imaginary sphere. Okay, let's take mass inside imaginary sphere is m dash. So what is formula? At this point field will be, due to outer part field will be 0, because this point is inside of outer part. This is part 1, let's take, this is part 2, let's take. So due to part 1, field at this point will be, let's take this is a point P. So field at P point is 0 out due to outer part. Field will be only due to inner part. Okay, second part, I assume mass of that second part is m dash. So here what would be field? Field will be G m dash upon, what is this distance? This distance is, let's take R. So this will be R. Problem is that here only we have to calculate this m dash. M dash is not mass of complete sphere. So here I can calculate assuming uniform density. Okay, so I can calculate here mass m dash equal to volume 4 by 3 pi r cube. This is volume into density. But what is density? Density is not given, complete mass given. So complete mass upon complete volume is density. Okay, so I can write here complete mass upon complete volume, that means 4 by 3 pi r cube. So this value is 4 by 3 pi cancel, 4 by 3 pi cancel. I am getting here m dash equal to m into r cube upon capital R cube. So this is small m mass we have calculated. So field value is E equal to G upon R square, and m value is m r cube upon capital R cube. So this value is Gm r upon R cube. So this is value I got. This value is Gm r upon R cube. This value is important. In vector form, again in vector form, if I'm writing, so vector form it will be Gm and R upon R cube. So let me write R vector, so this will be negative. Okay, because always it will be towards the mass. In vector form, if I'm writing in vector form, so minus Gm R vector upon, so any point field will be towards center. Okay, now if I'm plotting curve, so this is, let's take here, this is center, this is gravitational field, and in value I am plotting. Okay, so in value this will be from center to surface, it will increase linearly, it will increase linearly. Okay, again it will decrease. Okay, so this E will be proportional to 1 upon R square. Here E will be proportional to R. So from center to surface E will increase linearly, and from surface to infinity it will decrease as per this relation. Okay, so what is maximum value? This maximum value is Gm by R square. Clear? So here you have to know what is maximum value of E, how it is varying inside, outside. So this formula is very important. This one and this one will behave like outside and at surface similar. Okay, variation is inside. Here inside field 0, here inside increasing linearly. Okay, this is how we have to calculate. This is all about gravitational field. Now gravitational field topic is over. Okay, so in next lecture we'll complete gravitational field. Okay, gravitational field due to gravity. Okay, so this is for today. Thank you so much.